let's take a look at a little layer of complexity to what's going on here. Now I want to solve for sine of 2x equal to negative 1/2. And there's a lot at play here. Think about the graph of sine of 2x. I've essentially changed my period, and I'm making this wave repeat more quickly than if this period were a regular 2 pi. So I actually have a little Desmos visualization for what's going on here. So here I have some sort of a regular angle. This is like my normal unit circle angle rotating around the unit circle. And I want us to consider what would happen if and I actually have this thing going all the way up to 3 pi, since that is what the boundaries are for this particular example. And I want us to think about what would happen if I added this 2 theta in here. And so by turning this on, I'm adding another angle that's always double what this theta 1 is equal to. And so what's happening is this thing is spinning around a little bit more quickly around the unit circle. That should make sense. The period of sine of 2x is pi, and so that means that I'm more quickly moving around my unit circle if this angle is always double this angle. So hopefully that sort of makes some sense. And now what I'm trying to look at when my solutions will equal 7 pi over 6 and 11 pi over 6, which is what we'll get to by having the sine equal negative 1/2, we'll notice that within the normal graph, or the normal theta, I only hit once and twice these two angles within 3 pi. That's what I just found before. That's why I had two solutions to the previous answer. But if I were to now add this sine of 2x, or increase my, speed up my period to pi, now you'll notice that I have 1, 2, I'm going to hit it again, 3, 4 times within 0 to 3 pi that I actually hit. Oh, there's another one. There's another one. So it looks like I have a total of 6 intersections, or 6 times this new angle crosses over these two solutions now that I've changed my period. So that's a lot at play here. I want you to kind of think about what's going on. You can also think about what the two graphs look like, your normal sine curve and your, well, let me turn this on too. There's a lot going on. Here's, in blue is your sine of 2x, and in black is your sine of x. And we're seeing that we are repeating this wave 2 times where I used to have it occur just once. So now it's getting a little visually busy here. But really what I want to get at is that changing the period, it changes our number of solutions in that same restriction. So let's now get back into how we could actually solve this algebraically. So if I wanted to solve this, what I'm going to do first is I'm going to take a look at whatever this complex piece is, and I'm going to just remove it and put something simple there. So I'm going to call this a u substitution. I'm going to let some new variable u equal 2x. And so what I'm going to do then is I'm going to just rewrite this as the sine of u equals negative 1/2. And now that I've done that, I'm going to solve for u. So this is essentially the same problem that I had before. U is going to equal these two solutions, 7 pi over 6 and 11 pi over 6. All right, and so now that's great. I've solved for u, but I really want to solve for x. So at this point, I'm going to go back and resubstitute in 2x. So I'm going to say that 2x is equal to 7 pi over 6 and 11 pi over 6. And so now I want to solve for x, so what I'll do is I'll solve for x. And the way I'll do that is I'll multiply 2x by 1/2, and I have to do that to both of these solutions as well. So I'm going to multiply these solutions by 1/2 as well. And so this is going to mean that I have two solutions, 7 pi over 12 and 11 pi over 12. So these solutions are already different than what I had before with 7 pi over 6 and 11 pi over 6. But now what I need to do, just as I did before, is I need to add the period. Essentially what I'm doing is, again, I'm finding coterminal angles. But this time a coterminal angle isn't given by adding or subtracting 2 pi, but I'm actually adding just my period of pi to my solutions. And the reason why the period is pi is because I've got a b-value of 2. 2 pi over 2 is pi. This wave is occurring more frequently than the regular sine curve. So what I'll do then is maybe I'll hop down here, and I'm going to rewrite my two solutions, 7 pi over 12 and 11 pi over 12. And now let's add my period of pi. And I'm going to just write this as 12 pi over 12. So I can start thinking with the same denominator. And you know what else I'll do too? Since I'm adding pi's over 12, I'm going to rewrite this domain restriction as 0 is less than or equal to x, which is less than or equal to 36 pi over 12. This is kind of like my maximum number. So that's just going to help me process this. So I'm going to start adding 12 pi's over 12. So this will be 19 pi over 12. And then if I add another 12, that's going to be 31 pi over 12. And I can already see that if I were to add another 12 pi over 12, I'd have 43 pi over 12, and that has exceeded my maximum. So this I'm not even going to include. To my 11 pi over 12, I'm going to add another 12 pi over 12, so this would be 23 pi over 12. Add another 12, that's 35 pi over 12. And then again, I'm going to hit outside of this window. So all of my solutions, now I actually have 6 solutions to this specific problem. And it looks like I've kind of built a crooked house here, but those still are my solutions. All 6 of these satisfy this equation. And I could check this. I could plug it into a calculator. I could take the sine of 2 times 35 pi over 12, make sure that's equal to -1/2, and that would be right as rain.